Hello everyone, welcome back to my channel. When two vectors of magnitudes p and q are inclined at an angle theta, the magnitude of their resultant is 2p. When the inclination is changed to 180 minus theta, the magnitude of the resultant is halved. Find the ratio of p to q. Here I've illustrated the scenario for p and q with a magnitude of the resultant being 2p. That's diagram A. And B is for the magnitude being changed, with the inclination, being changed, and also the magnitude being halved. So inclination changed to 180 degrees minus theta. Now, as in previous problems I've solved, we solve this because they're not perpendicular, they're non-perpendicular vectors, so we use the cosine rule. And in this case, we're not using any numbers, so we'll do it in a general way. So for diagram A, we have 2p squared, so that's the resultant squared, p squared, q squared, minus 2pq cosine theta. And for diagram B, we have p squared equal to p squared q squared minus 2pq cosine theta. Right, if we simplify, we'll call this equation 1 and this one equation 2. Or this is for A and this is for B. A is equation 1, represents equation 1, or 1 represents the diagram A, and 2 represents the diagram B for calculating the resultant. Now we're going to rearrange, just use some algebra, rearrange this. Equation 1. If we square the left-hand side, we'll get 4p squared. So if we have 4p squared and we take away p squared, we'll have 3p squared left. So immediately we can write that we have 3p squared. And we'll have on the other side of the equation, we have 2pq cosine theta. Minus q squared, and on this side we have 2pq cosine theta. Please check this. So I've squared the left hand side and I've rearranged, so this will become 4p squared. If I minus p squared from it, it becomes 3p squared. I have a q squared with it, which when I move over to the left of the equal sign, it becomes minus q squared, and that's why we have this here. I've just swapped the sides, and 2pq cosine theta remains the same. Now, with equation 2, we rearrange to get, if we have p squared here, this will cancel with this p squared. So all we'll have left is q squared on one side. And if we move this 2pq cosine theta over to the left, it becomes positive 2pq cosine theta. So we have the same here, 2pq cosine theta is equal to q squared. If you're wondering why this equation has negative and this one has positive, it's simply that cosine of 180 minus theta is actually minus cosine theta. So it actually makes this sign positive in equation 1. Now we can simplify this. Now if both of these are equal to 2pq cosine theta, then we can write that q squared is equal to 3p squared minus q squared. So q squared is equal to 3p squared minus q squared. And if you simplify this, we'll have 2. If we move this minus q squared over to the left, we have 2q squared is x equal to 3. Oops, let's write that nicely. 3p squared. Now, we're actually attempting to find the ratio of p to q. So if we take the square root of both sides, we have p to q is equal to the root of 2 to the root of 3. So that's the ratio of p to q. We're working in a general sense here, no numbers. We're just given a scenario which we've used the cosine rule here with a bit of algebra. We rearranged, simplify, and found q as root 2 to root 3. Thanks for watching this video. Please like and subscribe to my channel. Bye for now.